Let's look at problem B. In problem B, we have the square root of 5 plus the square root of 6 all over the square root of 3 minus the square root of 2. So the problem is that we have square roots everywhere in the denominator. And if we have more than one piece in the denominator, there's only one way to get rid of square roots in the denominator, and that's to use what's called the conjugate, like we did in part A. So our denominator has a square root of 3 minus 2. The conjugate would be the same thing, but with the reverse sign in the middle. So that would be the square root of 3 plus the square root of 2. So that's what I'm going to multiply the bottom by to get rid of the square roots. But if I multiply the bottom by that, I have to multiply the top by the same exact thing. Now, I want to make sure that the denominator works out because this was our main problem, was I can't have square roots in the denominator. So let's multiply out the two denominators, and just like before, that means I need to FOIL. So I'll start off by doing, let's see, the square root of 3 times the square root of 3, which is 3. The square root of 3 times the square root of 2 will get me the square root of 6. Keep on going. Negative square root of 2 times square root of 3 will get me negative square root of 6. And negative square root of 2 times square root of 2 will get me negative 2. So we've got a positive square root of 6 and a negative square root of 6. Those two will just cancel out. I also have a positive 3 and a negative 2, which are like terms, so they can just be added normally. What happens when you add a 3 and a negative 2? You just get a positive 1. Now, because I don't have any roots in the bottom, that's what I wanted, now I feel pretty safe multiplying out the two tops. Well, then I have to multiply out square root of 5 plus the square root of 6 times the square root of 3 plus the square root of 2. Again, not pretty, I'm foiling. So square root of 5 times the square root of 13 is the square root of 15. Square root of 5 times the square root of 2 is the square root of 10. Keep going. Square root of 6 times the square root of 3 is square root of 18. And square root of 3 times the square root of 2 is the square root of 12. Now, that is not very pretty because none of those are like terms. So we're kind of stuck with them. We're stuck with the square root of 15, the square root of 10, let's see, the square root of 18, and the square root of 12. And notice we are dividing this whole thing by 1. Remember, if the denominator of a fraction is 1, we don't even need to write it. So we can just lose that denominator of 1. Now, the top, the square root of 15, there's nothing you can do with that. And the square root of 10, there's nothing you can do with that. But, let's see, we can break down 18. 18 can be broken down into 9 times 2. So that would break down into 3 square roots of 2, because the square root of 9 is 3. The 2 you'd be stuck with, though. And I can also work on the 12. The 12 is 4 times 3. So I can, when I take the square root of the 4, it'll come out as a 2. The 3, again, I'm stuck with that. So it'll give me 2 square roots of 3. And again, the 1 on the bottom does not have to be written, so we are done. Notice none of these are like terms, so I can't add or subtract them. They've all got to stay as separate individual terms. Let's try one last one. On C, we've got 3 square roots of x over the square root of x plus the square root of y. So, again, I've got square roots all over the denominator and more than one piece. I have to use the conjugate, which means take the denominator and just switch the sign in the middle. So I'm going to multiply by its conjugate, square root of x minus the square root of y. So square root of x minus the square root of y. If I do that to the bottom, I have to multiply the top by the same thing, square root of x minus square root of y. But I do want to make sure that my denominator works out because that's what's important. So I have to FOIL it out just like before. So foiling, square root of x times square root of x will get me x. Square root of x times negative square root of y will give me negative square root of xy. Keep on going. Square root of y times square root of x will get me positive square root of xy. And square root of y times negative square root of y will get me negative. Remember, the two square roots will cancel out, leaving you with y. Notice, just like before, we've got a negative square root of xy and a positive square root of xy. They're the same thing, just one's a plus and one's a minus, so those will cancel out. So, on the bottom, not everything disappears, but everything with a root disappears, which was the goal. We do still have stuff on the bottom. We still have an x and we still have a minus y on the bottom, but I don't have any roots, and that's really all that matters. Now I have to see what's left over on the top. Well, I've got a 3 square roots of x times a square root of x minus square root of y, so I need to multiply that out to see what happens here. So the 3 square roots of x times the square root of x, well, I'll have a 3. And then remember, the square root of x times the square root of x will just leave you with an x. And then I'll have a minus. Well, then I have to do my last piece. 3 square roots of x times the square root of y will give me 3 square roots of xy. So on top, I'm left with a 3x minus 3 square roots of xy. It's not pretty. And yes, I do have square roots on the top, but that's okay. Remember, rationalizing just means I don't want square roots on the bottom, which I don't have any, so I am done. This is it. So my final answer is 3x minus 3 square roots of xy all over x minus y.